All right, these are a few problems that are really just some review problems from pre-cal, um, and we're just going to evaluate some different trig functions or inverse trig functions, or maybe some compositions of them, mostly with the inverse trig. Inverse trig takes ratio of sides of a triangle and gives you the angle of the triangle. So with the regular trig functions, you plug in an angle and you get a ratio of sides of a triangle. So here we're going to evaluate the arc cosine of a negative 1 over 2. And remember, the cosine on the unit circle is going to be the x coordinates, and arc cosine, or the when we're dealing with arc cosine, we have to restrict our angles between 0 and pi. So in quadrant 2, that's where we're limited to. So this is where this arc cosine of negative 1/2 is going to dump our angle into. So our coordinate's going to be negative 1 over 2, comma, root 3 over 2. And that's going to be the point on the unit circle. Now, the root 3 over 2 is bigger than 1/2, and so this coordinate here, that's the sine, and the sine is going to be with the bigger angle being 60 degrees. So this angle here is going to be 60 degrees. Okay? Now we got a straight angle here, that's 180 degrees. Okay? So this angle should be 120 plus 60 will be 180. So 120 degrees times, remember desired units on top, so conversion is pi over 180. So this will give me 2 pi over 3. So that's what my angle is right there. And if you have your unit circle memorized, that makes this stuff much easier. Okay, so that is going to give me 2 pi over 3, and that's my angle. Okay, let's look at another one. We'll look at the arctan of 1. Okay, remember tan is sine over cosine. So if we're going to get a ratio of 1, that means both the sine and the cosine are going to be identical. So when you look on your unit circle, that's going to be at the 45-degree angles, and arctan is defined between pi over 2 and negative pi over 2 on your unit circle, so that limits us to quadrant 1. And that angle there is going to be pi over 4. Okay. So let's do something a little bit more fancy. And then we're going to look at the cotan of arc sine of 3/5. The arc sine, when we have a restricted angles, we're looking at the sine in quadrants 1 and 4. That's pi over 2 to negative pi over 2. Since the ratio 3/5 is positive, that tells us we're in quadrant 1. Okay, so the opposite is 3 and the hypotenuse is 5. This is a 3, 4, 5 Pythagorean triple, so you can use Pythagorean theorem to find that missing side, which is going to be 4. Okay, all right, so remember, arc sine of this block, that stuff there, that's just that angle. So we're going to find the cotan, and the cotan is going to be the adjacent over the opposite. So adjacent over the opposite. And that's all you had to do. It's very visual, so I would draw triangles if I were you. I often picture the triangles, or I draw them out as I'm working through these. Okay, let's look at maybe one or two more of stuff that gets a little bit more advanced. We're going to look at the tan of arc cosine of negative 5 over 13. Okay, so the ratio of sides of the triangle is negative. Where cosine is negative is quadrants 2 and 3. When we want to have an inverse of cosine, we have to restrict it from 0 to pi, so that would restrict us to being in quadrant 2. So we're going to be in quadrant 2 here. Okay, so there's our adjacent side of negative 5, and our hypotenuse is 13. 13 squared is 169. 5 squared is 25. 169 minus 25 is 144, and the square root of 144 is 12. So 5, 12, 13 is also a Pythagorean triple. Okay. And arc cosine of negative 5 over 13, whatever, that's just this angle. Okay. The tan is the opposite over adjacent. So this is just going to be 12 over 5, and I like to put the negative out in front. Okay, that's it. Okay, let's do one more. We're going to look at cosine of the arc sine of 5x. Okay. Again, I'm going to either be in quadrants 1 or 4 for us to have an arc sine. We'll go ahead and assume it's positive. Sine is opposite over hypotenuse. And the easiest way to get 5x would be 5x over 1. So we will say our opposite side is 5x, and our hypotenuse is 1. And then if we use Pythagorean theorem, we're going to do 1 squared minus 5x squared, and then take the square root, and that's going to give us this missing side. Okay? And then the cosine is just going to be the adjacent, which is that this mess we just found over 1. Okay? And then I decided that I feel like it looks better if I write it as 1 minus 25x squared. You can leave it as 1 minus 5x squared. It'll be helpful to go in between the two interchangeably for some other stuff we're going to do in this class. Okay, so this is all just review from trig or pre-cal. It's not terribly difficult, but if you haven't done it for a while, it does take a little bit of practice to get yourself back and comfortable with this material again.